Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others in need of assistance with these topics. So today we're going to be going over derivatives, and we're going to be using the chain rule in order to find derivatives, and we are going to be finding the derivative of the expression shown on the screen here. So first thing I'm going to do is I'm going to rewrite this little square root portion because utilizing the chain rule, best to have everything in terms of a power. So what I'm going to write here is just t cubed minus 8 all to the 1/2 power, since taking to the square root is a 1/2 power. So now I'm going to use the chain rule. In order to use the chain rule, I have to set up two variables. So I'm going to set up a u variable and an f variable here. U will be everything inside of my power. So that will be t cubed minus 8. And then my f is essentially everything else in terms of u, because essentially what I have now is u to the 1/2 power. And that's what f is going to be. F is going to be u to the 1/2 power then. So to apply the chain rule, this is what we're going to have with these new variables. So essentially, I've taken this entire expression and turned it into u and take it to the 1/2 power in terms of this f equation, but I'm still finding the derivative with respect to t. So what that changes is d dt into df dt, which the derivative of expression f with respect to t is equal to df du multiplied by du dt. So the first one is just the derivative of my f with respect to u, which would be this one. And then the second one is the derivative of my u with respect to t, which would be this one. And then we multiply those together. So we would have df du is equal to d du of u to the 1/2 power. And where d dt is just d dt of t cubed minus 8. So I'm going to take this and multiply it by this. So let's scroll down here. So my chain rule expression of df dt is equal to this first portion of the derivative with respect to u of u to the 1/2 power, and then multiply that with the derivative with respect to t of t cubed minus 8. And we just have to solve for each one of these. So with the first one, we're going to drop that power down, which most of these are in the expression of ax to the b. So when you take the derivative with this with respect to x, it's going to be ax b to the minus 1. And then you drop that constant in front and multiply it through. So in doing this, we would have the 1/2 dropping down. We would have our constant u, or our variable u, sorry. And then we would have our power minus 1. And that would be our first portion. We'll simplify that later. And then the second portion, repeat the process. We're going with respect to t now. So we take the power, drop it down in front, have our variable t, and then our power minus 1. And then whenever you have a constant here and you're taking a derivative of a constant that does not have the variable attached to it, that will turn to 0. So 8 becomes 0. So simplifying this down a little bit, what I have here is 1/2 u to the minus 1/2 power. All of that times 3t squared, which if you want to write this out, you can write it out as 3t squared divided by 2 square root of u, since the minus 1/2 power is a square root being divided. So it'd be square root in the denominator. Well, we're not 100% done yet because we still have to plug in u in terms and put it in terms of t. Well, what is u? Well, we wrote that out at the very beginning. U is t cubed minus 8. So just plug in t cubed minus 8 here. And then this expression becomes 3t squared all divided by 2 times the square root of t cubed minus 8. And that is our final answer. And of course, you can simplify that further down if you want. If you can change the answer a little bit in the denominator, whatever you feel most comfortable with. But this is the most simplistic version of that expression, and this would be your answer. Just depends on what your answer should look like whoever's grading it, right? So I hope this video is helpful. And if you want to see more problem solved this Friday, please check out other videos on our channels. We're trying to upload daily. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel. Thank you for watching, and I hope you have a great day.